In this video we are going to look at how to slice a topographical model into different sections like this, so you can actually you see the lines here, I suppose. We have contours, right? And we can simply divide a model into these slices, and then we can project the curves onto the C-plane, so that we in top view have the possibility of cutting these out with a laser or a CNC machine or whatever you have at your disposal. The thing is though that we need a lot of materials. So we have here, for example, I have 10 millimeter distance between the contours, and which becomes then 13 different slices flat material that we have to cut. But then again, if we do every second one, we will be able to make this out of only two different pieces of material. And then I mean like this, like we take every second one, like we see here, the green ones, and cut from one piece, and then we do every second one, but the first and the third in the order in the next one. So this would be the 0th, the second, and the fourth. So the even numbers, so to say, and these would be the odd numbers. Then the first, the third, the fifth, and so forth, which would render to this. So we will have one model that you see on the left here, this one, and you will have another model here. So you will cut that in one go, and then you will mix these. You know, they will overlap each other so that they don't fall through, and then you will have the whole topography like this, made from 2D cut pieces of wood or material or whatever material you're using. The only problem though is if you use contour like this, it works indeed. You can simply swap between second and between every second line by simply doing a cull pattern and write false true in the pattern and true false in the other pattern. That means that you can jump from, you just skip, you cull every second contour line. The only problem though is that when there are more peaks on a model like this, you will have a problem with the mixing here, because they will simply not understand what we're telling it to do. So I can illustrate that here. So we have to show you an alternative for making contours, which is actually a bit faster as well. So here, for example, we have a big problem, right? Look at the models, how they turn out. It's not every second curve anymore. It's every second curve, well, in the order it's been given, and which means that here is obviously the 0th, here's the second, here's the 4th, and then we have another curve here. They are not joined, so the 6th curve will jump somewhere here. It's not like every second in the set direction, and this is what we can change actually. So if you're trying out with contours, consider the alternative that I'm going to show you here, which is simply to cut it in the set direction using this, which is located on intersections. So we are using a B-rep and a plane. So we're simply constructing planes in the set direction, and then we use the cull pattern again, the same thing, false true and true false. And here are all the planes. I can show them here like that, and they are situated, well, it doesn't really matter because a plane cuts infinitely, it just covers the whole working space into infinity, so it doesn't really matter where it's located. And in this case, we have the lines are selected, you know, every second one, true, false, and false, true, and it doesn't really matter what we do with the model. It will always work because this is created based on a series of numbers here instead. So I'm using a top value, so it doesn't. I'll explain that later. The highest value possible, and we are using also. Here is the height between the lines, which we generate x times through series. So we multiply it with everything's coming out here. So you see it's like times 1, times 2, times 3, times 4, and so forth, which means that we're going to build planes in the z direction with help from an x, y, z point, turns into planes, and then we can select every second plane. So here, for example, then false, true, and true, false. And then again, we can project it. So you can bake this into one layer, and the other one you can bake into another layer, and then you can cut this with the laser or with a CNC or whatever machine you have at your disposal. So this is of course based on your having a topographical model already. As you can see here, I have one like this already. So I suggest you look at maybe another one of my videos or build something similar to this, so you can do this setup, add it to your model. And this is the setup I'm going to do. So it's not so many components really, maybe 10 or 12. Yeah, so I'm gonna build this from scratch now. So what I want to do is to I want to cut this model in the Z direction using a plane. So the component we're going to use is brep and plane, looking like this. So we zoom in and we hover on it, and it says solve intersection events for brep and plane, otherwise known as a section. So we're making sections through the whole model. What we need then is a brep or a surface, which is the same thing, and I have it here already. So as I said before, you need to have a topographical model. Well, not similar to this, it can be whatever actually. So I will attach that here, and it's already actually doing something, because on default there is a world XY plane built into the section, the brep section, brep plane section here. What we need to do here is to add more planes. And how are we going to do that? Well, we have to think about what we want to do first. We want this to behave similar to contouring, right? So first we need to actually, we can actually set a slider already, and just take it from, for example, from 0 to 10. Well, 0 is never going to be really 0, right? So maybe it's 1 to 10. And this slider is going to decide how high these points are going to be. So what you can do with this, I mean, if you open a point, an XYZ point, this could be a section already, or a plane already, I mean, because a point can be attached to a very normal initial, you know, with a black hexagon behind a plane like this. So you can just tell this component, if you open it from there, you know, you can tell that component to where it's positioned, and then it understands that it is a plane. So if I add my point, you see already what's happening. It's going up and down a little bit, at least, because I have a slide from 1 to 10, right? And then I can attach that to my section, and when I pull up and down, it's like that, you see that it's actually doing a cut already. That's quite good. The problem is we only have one. So I mean, the idea would be to add additional sliders. This is something you actually could do, but why do that when you can generate sliders, right? So let's just keep one slider here, and to to simulate or to generate sliders, the command series is very good. So if we go to sequence and to series and open that, and we hover that a little bit here, create a series of numbers. That's exactly what we want, right? So the first number in the series, 0, sounds pretty good. We can then get the very bottom of the model. And then we have the step size for each successive number and the number of values in the series. And that renders out already from 0 to 9 actually, because it's on default more or less. So what we can do here is to simply put in the step size, and then you will see something completely different. Then we have a lot of them already. So if I pull down here, you see it's gonna make very many big differences here. The thing is, though, that's really fast, a really fast thing to do. The thing is, we have to analyze our model a little bit, because this is like actually not giving us the correct height. You see, it's actually not taking the highest points. It's only a part of it, and that has to do with how many it's supposed to do, because this is on 10 already. We have to analyze the highest point in the model, divide that with this number, and then we get another number here, if it makes sense. Before we do that, though, we can already do the transition here. So if you go to Cal Pattern, double click Cal Pattern, which is also located here on sequences, right? And if you just attach this and attach it like that, like a little filter in between, you see it's taking something out. If you hover on the P, you see the default value is false, false, true, true, which you can change by right-clicking, go to Set Booleans, and this window is a little bit irritating something. So I will write false, true in one of them, and you see so now it's like every second one of them. And then I will copy both of these, and in the copied cal patterns, I will reverse that. So I will write, I will write in this window, I will write true, false instead. True, false instead of false, true. So now we have that situation we were looking for already. What is missing is simply a little bit of settings here, right? So given that you have some, this one is generated by a large series of numbers. You can also set a slider in here. Like if I take, here I have one already, I can just show that. If you know you're gonna have like top 130 of them, that's the highest value, then they're gonna do 130, but it's gonna unfortunately miss it because it's on top here. So that's not so good. What you should do is to divide that number with 4.4 on it, or well, the distance between them, and then put that in. You see? Still, it could be a little bit, depends on how high your model is. So if you could analyze how high this model is, you can do that in various ways. So for this, to get the highest number, you can do in various ways. For me, it's really easy, actually, because I could just take it up from these point generation here. I already sorted all the points, so I can do sort list, like this. Flatten the input here, and I just hover here to C, and I reverse that. And then the highest value comes automatically. And I can do a list item on that, because list item takes, oh sorry, not the wrong one. List item takes the 0th position, which then I can hover here to see, yeah, 122 obviously. Then I can use that. Then I have a parametric setup, which will always adapt to the height of my model. It doesn't matter what I do here. It will just, you see already on the left, it's actually taken the height of the model into account when it's building all those planes to cut with. That's one way to do it, but of course maybe you don't have these numbers, so I'll just show a quick alternative. So you can analyze your whole model here in a similar way actually. It's an awful lot of components. Maybe you can find it a little faster way than I can find. So you can take a union box, you can take, this bounding box, located here, located here. And then you can blow that up with a deconstruct brep, because then you can extract all the points, and the points is an indication of how high it is at its very top point. So then you can deconstruct the points by using here in the points, deconstruct points there, and then you get all the points. So the highest point in this case seems to be 97. You have to look at it as well and just try to see if that really is true. Well, I can see here that, well, it's very similar. It's just that it differs a little bit because of the curvature of my the surface grid, which actually is rebuilding all the points into building a surface from points. So that's why. But anyway, I can then use the same kind of sort list here, sort list, and then I see that I can reverse them. I don't have to flatten here. You see already that the cable is solid, and then I can do a list item at the end, so that I pick the 0th position. Yes, and then I have again the highest value of this structure. So I can use either this one or the one I made before. It doesn't really matter. Yeah, so this is more or less the setup. This one thing I can just hide for a moment, because I'm using now what I'm using is the numbers I've generated. Or you can use this depending on what data you have to build the structure. If you don't have data before that builds this, then you have to do this, right? If you have a model, for example, made in another manner. Yeah, and then you can simply then project these onto the surface, onto the plane. Project to plane, located here. Transform, fine. And I can just copy that to the other one, and then you can swap between those two, and you see that you have actually selected every second section of these. And it's very tight, right? So it depends on the machine you're using as well. Now I'm saying my material thickness is 10. You can also check that out here. Distance, is that around 10 maybe? Yes, it is. So you can then bake this and then export them as in the format that the laser cutter or the CNC machine use. Usually it's DWG or AI. So I hope you can use this for your projects or for your models. So thank you.